Now, before that, we have to learn certain concept related to generating function. As we know, we are saying gx equal to summation n from 0 to infinity a n x to the power n. Let this be the generating function corresponding to the sequence a n. That means a0, a1, a2, all this. Now, if we can take this is gx, or if you expand, you get this is nothing but a0 plus a1x plus a2x square plus a3x cube plus all this. Now, if gs equal to this much, then I can say about minus a0, this a0 term taking left hand side. So this gives a1x plus a2x square plus a3x cube plus, or simply in the summation form we can write summation n equal to the index 1 to infinity a n x to the power n. That means gx equal to n equal to 0 to infinity n x n, and gx minus a0 equal to n equal to 1 to infinity a n x to the power n. Similarly, we can write for gx minus a0 minus a1x, gx minus a0 minus a1x. So this will be a2x square plus a3x cube plus a4x4 plus so on. Or simply in the summation form we can write n equal to 2 to infinity a n x to the power n. In similar way, we can write for gx minus a0 minus a1x minus a2x square and so on. Now, you note these three terms. That means you can have gx equal to n equal to 0 to infinity a n x to the power n. Gx minus a0 is n equal to 1 to infinity a n x to the power n, and we got gx minus a0 minus a1x as n equal to 2 to infinity a n x to the power n. And similar way we can represent for other terms. Now knowing this, suppose I want to solve a reconciliation using generating function. Now you can consider this example. Consider this example. Suppose we want to solve a n equal to 5 a n minus 1 minus 6 a n minus 2 with the condition given a0 equal to 1 and a1 equal to 0. Okay, I want to solve this reconciliation using generating function. Here we learn use concept of generating function. Okay, now to solve this, what I do, this is a simple example. Corresponding to this we can solve any other example, so look it carefully. Okay, so you can say what I do. First step, in the first step I am taking the reconciliation as a n minus 5 a n minus 1 plus 6 a n minus 2 equal to 0. I am taking everything in one side. Now what I do, in the first step, multiply x to the power n and summing over n equal to 2 to infinity. Now look here, as the question is of the form a n minus 2, so we are taking summation from n equal to 2 to infinity. If the order of the equation is n minus 3, that means if the order is 3, then you can take the summation from n equal to 3 to infinity. If the question is of first order, then you can take the summation from 1 to infinity. Okay, but this question, as it is a second order equation, so you simply multiply x to the power n and summing over n equal to 2 to infinity. So the first step will give, after that we can get a n x to the power n summation n equal to 2 to infinity plus, okay, here my minus 5, so I can have minus 5 into summation n equal to 2 to infinity a n minus 1 x to the power n plus 6 summation n equal to 2 to infinity a n minus 2 x to the power n equal to 0. This is the first. Okay, everyone clear? Hello? Everyone getting it? Please, anyone?
Yes, sir.
First we multiply x to the power n summation over 2 to infinity, then we got this star. Now, in the next step, we want to make the index equal. Here a n x to the power n there, but here a n minus 1 x to the power n. I want to write it of the form x n minus 1. And similarly, here I want to write for x n minus 2. So what I do? First step, copy paste n equal to 2 to infinity a n x to the power n, but here x 1x outside. So minus 5x summation n equal to 2 to infinity a n minus 1 x to the power n minus 1. So similarly, if I take x square outside, then I get n equal to 2 to infinity a n minus 2 x to the power n minus 2 equal to 0. This is my second step. Okay, now I want to make the index equal. Here the index is a n minus 1 and here the index is n minus 1. Here index is n minus 2 and here index is n minus 2. So to make the index equal, you can have some rough work. If you take n minus 1 equal to some variable m, if we take n minus 1 as some variable n, then this from n equal to 2 gives m equal to 1 to infinity a m x to the power m. Here I am doing some rough work. Okay, I want to make the index equal, so n minus 1 is taking as some variable m, then n equal to 2 to infinity gives m equal to 1 to infinity mx to the power m. Similarly, here if I write n minus 2 equal to some variable m, then this gives m equal to 0 to infinity a mx to the power m. Getting it? What I'm saying? But in the power series case, we want to make the index some variable m. Now, so summation index changes. Now, as the summation is independent of your variable, in place of m, now you can write n. So knowing this concept in the rough work, we can directly write as here summation n equal to 2 to infinity a n x to the power n minus 5x. Now look here what I am writing. In place of m, I am writing n equal to 1 to infinity a n x to the power n, and in place of n equal to 2 or m equal to 0, I can write n equal to 0 to infinity a n x to the power n equal to 0. Clear, everyone? The quick step. Clear? Everyone?
Yes, sir.
Okay. Now, as we have got some certain terms, so looking into my previous one, this note gx equal to 0 to infinity, gx minus a0 equal to 1 to infinity, and gx minus a0 minus a1x as n equal to 2 to infinity. So I want to represent this summation in terms of g. So in place of n equal to 2 to infinity a n x n, what can I write? I can write gx minus a0 minus a1x. First, minus 5x. Here what I can write? I can write gx minus a0, and third term 6x square. This is our gx. Okay. Now writing the summation in terms of gx. Now what I do? I will apply my initial condition. As you know, given that a0 equal to 1 and a1 equal to 0, given that a1 equal to 1 and a0 equal to 0, just substitute here. So this gives first gx minus, in place of a0 1, and in place of a1 is 0. So this term becomes 0, minus 5x gx minus a0 equal to 1 plus 6x square into gx. Now after writing that, I will little bit simplification. So gx minus 1 minus 5x gx plus 5x plus 6x square gx equal to 0. Now taking all the gx term one side, I can have gx into 1 minus 5x plus 6x square, and remaining is minus 1 plus 5x equal to 0. Minus 1 plus 5x equal to 0. Or simply I can have gx equal to, taking this side, 1 minus 5x divided by 1 minus 5x plus 6x square. We can write gx as 1 minus 5x divided by 1 minus 5x plus 6x square. Up to this, everyone clear? Hello?
Yes, sir.
Okay. Now what I do? Now, as denominator is 1 minus 5x plus 6x square, I can make it factorization. So this can be written as 1 minus 5x divided by, as you know, after factorizing, you can have 1 minus 2x into 1 minus 3x. Okay. Gx equal to 1 minus 5x divided by 1 minus 2x into 1 minus 3x. Now, next work is to make partial fraction. Make partial fraction to this function. So already you know how to do partial fraction in your electrical class or in your class 11 or 12 also, during integration, you know. So just I am doing that. I want to make a partial fraction to 1 minus 5x divided by 1 minus 2x into 1 minus 3x. Suppose I want to write it in the form of a divided by 1 minus 2x plus b divided by 1 minus 3x. So as you know, this gives a into 1 minus 3x plus b into 1 minus 2x gives 1 minus 5x. Okay. Now when you put x equal to 1 by 3, when you put x equal to 1 by 3, a into this part gives 0 plus b into 1 minus 2 by 3 equal to 1 minus 5 by 3. So what can I say here? 3 minus 2, that is b into 1 by 3 equal to minus 2 by 3. So we have b value as minus 2. Similarly, when you put x equal to 1 by 2, when you take x equal to 1 by 2, a into 1 minus 3 by 2 plus b into 0 give 1 minus 5 by 2. So little bit simplification, this gives how much? 2 minus 3, that is minus a by 2. Here 0 equal to 2 minus 3 2 minus 5 minus 3 by 2, or we got a value equal to 3. Okay, this is as well a partial fraction method. So after partial fraction, what I got? I got that 1 minus 5x divided by 1 minus 2x into 1 minus 3x as a divided by 1 minus 2x, that is 3 divided by 1 minus 2x, plus b divided by b is minus 2 divided by 1 minus 3x. Okay, and this is my gx. So as we got gx as 3 divided by 1 minus 2x minus 2 divided by 1 minus 3x. Now I apply the power series method, or as I know in my previous class, that the geometric series 1 divided by 1 minus ax is summation n equal to 0 to infinity a to the power n x to the power n. So this can be written as 3 into summation n equal to 0 to infinity 2 to the power n x to the power n. Similarly here minus 2 into summation n equal to 0 to infinity 3 to the power n x to the power n. Now taking all these as a whole, I can have summation n equal to 0 to infinity 3 into 2 to the power n minus 2 into 3 to the power n with x to the power n. And we know, and as we assume that gx as summation n from 0 to infinity a n x to the power n. So by comparing what I got a n equal to 3 into 2 to the power n minus 2 into 3 to the power n, and this is the solution of the given recurrence relation. Okay, this is the method using generating function how we solve the recurrence relation. Okay, everyone clear? Clear to all? Hello?
Yes, sir.
Then look here.
Yes, sir.
Basically, to solve one question, the how many method involved? In first part, you multiply x to the power n and summation. You have first. Okay, you have first. Multiply x to the power n summation. कर दिए. In the next step, take x outside, here x square outside. Second step. Okay. In the third step, make the index equal. Okay. Now, in the fourth step, you write the index in the form of generating function. After that, apply your condition, the initial condition given, then taking g one side and another baki all the function right hand side. Now next make the partial fraction. After doing partial fraction, just retrieve g in terms of summation for and comparing with the an term. Okay, this is the method using generating function how we solve a recurrence relation. Okay, clear up to this?
Yes, sir.
Okay, so let's solve another example. This is one question we have solved for the homogeneous one. Okay, no extra n term present. Now I want to solve one non-homogeneous equation. Okay. Now take this example. Take this example. Solve an minus 3an minus 1 equal to 4 to the power n minus 1. an minus 3an minus 1 equal to 4 to the power n minus 1 with given a0 equal to 1. Okay, I want to solve an minus 3an minus 1 equal to 4 to the power n minus 1 with condition a0 equal to 1. Now, see here, what is the order of this equation? 1. So, multiply x to the power n and summing over n equal to how much? 1 to infinity. So, we have an x to the power n summation n equal to 1 to infinity minus 3 summation n equal to 1 to infinity a n minus 1 x to the power n equal to summation n equal to 1 to infinity x to the power n 4 to the power n minus 1. Okay. Now what I do? Here taking x outside in the second step. So I take n equal to 1 to infinity a n x to the power n minus 3 taking x outside. I have n equal to 1 to infinity a n minus 1 x to the power n minus 1 and here again taking x outside, I can have n equal to 1 to infinity 4 to the power n minus 1 x to the power n minus 1. Now next step, I want to make the index equal. So what I do n equal to 1 to infinity a n x to the power n minus 3x. Now, if you take n minus 1 as some variable m and replacing that m by 1, then here m equal to 0 to infinity, or you can write n equal to 0 to infinity a n x to the power n equal to here x, same thing, n equal to 0 to infinity 4 to the power n x to the power n. Okay, दिख रहा है ना clearly? Hello everyone, is it
Yes, sir.
visible? Right side थोड़ा blur जैसा लग रहा है, फिर दिख रहा है शायद. Now in the next step, what I do, to represent this in terms of g. We want to represent this in terms of g. So what is this much? We बोले this is gx minus a0 minus 3x with gx. Now what can I write? As I know, look here, 1 divided by 1 minus ax is n equal to 0 to infinity a n x to the power n. We know this formula. So I can write this x here, 4 to the power x to the power n is written as 1 divided by 1 minus 4x. Now put the value of condition. What is the condition given? A0 value equal to how much? A0 value is how much? A0 equal to how much given?
1.
1 minus 3x gx equal to here x divided by 1 minus 4x. Okay. Now gx into 1 minus 3x can be written as here 1 plus x divided by 1 minus 4x. This minus 1 taking this side. Okay. Or by simplifying. Okay, next step I will simplify. So here gx 1 minus 3x. Now simplifying this gives 1 minus 4x. Here 1 into 1 minus 4x, 1 minus 4x plus x, that is 1 minus 3x divided by 1 minus 4x. Okay, that means what I got? I got gx into 1 minus 3x as 1 minus 3x divided by 1 minus 4x. Now cancelling 1 minus 3x from both sides, I can have gx equal to 1 divided by 1 minus 4x. Now as it is a simple form, it is not required any partial fraction term, and as we know, now as a whole you can write gx as summation n from 0 to infinity a n x to the power n, but here this is nothing but n equal to 0 to infinity 4 to the power n x to the power n. So by comparing, what I got, a n equal to 4 to the power n is the solution. Easy? Easy? क्या कुछ डाउट है? हेलो, everyone clear?
Yes, sir.
Okay. Now, let me find some example or some question, more question related to generating function. What नहीं मिल रहा है. Okay. Now, there are another certain type of question related to generating function from literature term. Okay, you can take this one example or question. Okay, question is determine the discrete numeric function corresponding to the generating function az. देखो टर्म चेंज किया है, ये 2007 का क्वेश्चन है. az इक्वल टू 1 डिवाइडेड बाय z स्क्वायर माइनस 5z प्लस 6. Okay. So to solve this, what it is asking for? It is asking for the numeric function corresponding to the generic function. That means you have to find the n term. Okay. Now, as az equal to 1 divided by z square minus 5z plus 6. Already we have solved this. As we can write as z minus 2 into z minus 3, and after now next work is to make partial fraction. To this. Can we do it? I can write let 1 divided by z minus 2 z minus 3, as already a is used. So alpha divided by z minus 2 plus beta divided by z minus 3. So I can have alpha into z minus 3 plus beta into z minus 2 equal to 1. Now when put z equal to 3, this gives alpha into 0 plus b into 3 minus 2 equal to 1. Or I can have beta value equal to how much? कितना ये लिखा हूँ ना z-2 z-3 5z-2 beta z-3 alpha into z-3 plus beta z-2 equal to numerator is 1. So alpha into when we put z equal to 3, this gives z equal to 3 minus 2, here 1. So beta equal to 3 minus 2, 1, beta equal to 1. Now when you put z equal to 2, this gives alpha into 2 minus 3 plus beta into 0 equal to 1. So here alpha equal to minus 1. Okay, so what we have, hence Az is written by alpha into z minus 2, alpha equal to minus 1 divided by z minus 2 plus beta is 1 divided by z minus 3. Now minus here summation n from 0 to infinity 2 to the power n z to the power n plus summation n equal to 0 to infinity 3 to the power n z to the power n, and as we are saying az equal to n equal to 0 to infinity a n z to the power n. So comparing, what can I say? A n is how much? 3 to the power n minus 2 to the power n. Answer. Right? Clear to all? Hello?
Yes, sir.
मिस्टेक है, यहाँ पे मिस्टेक है, सॉरी यहाँ पे मिस्टेक है. What is the mistake? Look here. I know the formula 1 divided by 1 minus az 0 to infinity a to the power n z to the power n. ये इसी फॉर्म में है क्या? Not az minus a, not az. Okay, तो यहाँ पे मिस्टेक. What will be here? देखो ध्यान से, az equal to minus 1 divided plus 1 divided by z minus 3. But I know the formula for 1 minus something z. So what you have to represent? First here minus 1, take 2 outside. Okay, or take better minus 2 outside. So this gives 1 minus z by 2. Look here. Plus here take 3 outside. Okay, or take minus 3 outside. So 1 minus z by 3. ध्यान से देखो मिस्टेक कहाँ पे था? Here is the mistake. What I exactly know? I know for 1 divided by 1 minus something z, not z minus something. Okay, look here. Everyone look here. Clear? Hello?
Yes, sir.
So now you can write minus 1 minus 1, 1 by 2. Here summation n from 0 to infinity z to the power n by 2 to the power n. Here minus 1 by 3 summation n equal to 0 to infinity z to the power n by 3 to the power n. Now comparing with this, I can have n equal to how much? 1 by 2 to the power n minus 1 by 3 to the power n, or simply you can write 1 divided by 2 to the power n plus 1 minus 1 divided by 3 to the power n plus 1. This is the answer, not this one. Okay, ध्यान से देखो, छोटा छोटा मिस्टेक हो जाएगा तो गलत है फिर. Okay, clear?
Yes, sir.
Now another type of question. Question. Find an expression For the generating function, of the numeric function, suppose 1 minus 2 3 minus 4 minus 5 minus 6 and so on. That means we have given the sequence and we want to write it generating function. Okay, so for answer part, we can know this is A0, A1, A2, A3, A4, A5. So suppose we have Gx equal to A0 plus A1x plus A2x square plus A3x cube plus all this. So exactly here Gx equal to A0 plus A1x minus 2x plus A2x square, that means plus 3x square minus 4x cube plus 5x4 minus 6x5 plus so on. It is writing in this form. Okay. We are saying that Gx equal to this much. Now, look here. We know that 1 divided by 1 plus x series, how much? 1 minus x plus x square minus x cube plus x4 minus x5 plus. Now, if I differentiate this with respect to x, d by dx of 1 plus x, then what I can say? I can have first term is 0, here minus 1 plus 2x minus 3x square plus 4x cube minus 5x4 plus, look here. Is it clear? देखो please, everyone please. इसका डेरिवेटिव, तो इसका डेरिवेटिव 1 का डेरिवेटिव 0 माइनस इसका डेरिवेटिव माइनस 1. Now this is nothing but your question given. के साथ एक माइनस टर्म. So this can be written as minus 1 outside 1 minus 2x plus 3x square minus 4x cube plus 5x4 plus so on. Now, if you differentiate this, what can you get? D by dx of 1 plus x. D by dx of 1 plus x. Anyone please? Derivative. Hello? 1 plus x का derivative. Hello? This is minus 1 divided by 1 plus x whole square. That is minus 1 minus 2x plus 3x square minus 4x cube plus 5x4 minus. Now minus minus cancel out. You can have 1 divided by 1 plus x whole square as 1 minus 2x plus 3x square minus 4x cube plus 5x4 minus. So hence clear? Without doubt. So here the solution is hence the generating function is 1 divided by 1 plus x. Okay. Everyone clear? Okay, these are certain type of examples related to generating function. Okay, I think we have completed most of the thing. In the next class, we will deal with certain type of advanced counting principle. Okay. Using permutation, combination, inclusion, exclusion, all these things. Okay. Now next there are 45 students, sorry 49, 49 students. Just write your roll number in the chat box for the attendance purpose. And listen, next class I will take your quiz test. Next class कब है तुम्हारा? Next class is on Tuesday.
Tuesday.
Okay, Tuesday there will be quiz test. Okay, everyone be present there. On Tuesday I will conduct one quiz test for you. Tuesday we have quiz test. Tuesday means on 22 June. Okay, thank you. Thank you all.
Thank you, sir.
Thank you.